In this chapter, we will talk about searching and sorting arrays. So let's talk about search algorithms. In the search algorithm, we want to locate an item in the array or in the list. So we have two famous algorithms to solve this problem, the searching problem. The first one is linear search and the second one is binary search. So linear search, also called sequential search. So you start with the first element, you check if this is the element that we are searching for. If not, we move to the second element and we check. If not, we move to the third element and so on. So we examine element by element until we locate the value that we are searching for. For example, this is array. Imagine you are searching the value 11. So first you check if the first value is 11. It's not. You move to the second one. Is it 11? Not. Third one, is it 11? Not. Fourth one, you find 11. So if you want to search for value 7, you will keep moving, searching for 7, and you will not find the value 7. So this is called linear search. So this is the pseudocode of the algorithm. Set found to be false. Set position to be -1. Position is the position if we find that value in the array. And we set the index to 0. While the index is less than the number of the array, like the size of the array, and found is false, if that value in the index is equal to the search value, we make found equal true, and we make position equal index, and we end if. And then we add 1 to index, and then we end the while. So we check again. If we didn't find, and the index is not, we didn't reach the end of the array, we keep repeating unless we found the element. If we found the element, we just return the position. So this is the code, the C++ code of that pseudocode. So we have a function search list, we have the array, we have the size of the array, number of elements, and we have the value that we want to search for. So we just translate the pseudocode into code, and this is called linear search. So here we have the while the index is less than the size of the array and it's not found, we check. If they are equal, we make found equal to true and position to index. We increase the index and then we go back to the while. So this is the linear search. What's the benefit of linear search? It's easy algorithm to understand, and the array can be in any order. There is no condition that the array have to be sorted. The disadvantage, it's inefficient, it's slow. For an array of n elements, let's say we have 1 million elements, so we need to make maybe 1 million comparison, right, in the worst case. Or in the average case, maybe you need to make 500,000 comparison, which is a lot. Imagine you have an array of 1 billion, so you need 500 million comparison. So it's not efficient. Binary search is another algorithm, but this requires the array to be sorted before. So how it works, we divide the array into 3 sections. The middle element on the in one side, let's say the left, and the elements on the right. So first we compare with the middle element. If we find the value in the middle element, we are done. Otherwise, if it's less than the middle, we go to the first half. If it's more than the middle, we go to the second half. And we repeat. So for the second, imagine it's in the second half. We go to the middle of the second half and we repeat and so on. So let's say we have this array and we want to search 11. So first we go to the middle and search for 11. We find 11, that's it. That's easy. But imagine you want to search for 7. First you go to the middle. Is 7 less than or greater 11? It's less than. So we know that 7 has to be in this side if it's in the array. Yeah, it cannot be this side because this array is sorted, right? So 7 has to be here. Again, we go to the middle of this part So the middle is 3. We compare 7 with 3. 7 is greater than 3. So 7 has to be here if it exists. We compare 7 with 5. 7 is not equal to 5. So this means that 7 is not there. So we only need 3 comparisons. But if we apply linear search, we need 1, 2, 3, 4, 5, 6, 7 comparison to know that 7 is not there. So this is the pseudocode of the binary search, and this is the code of the binary search. We will talk more about it in the lecture and the exercise. So the benefit of binary search, it's much more efficient than linear search. So usually you need log-n comparisons. Like for example, if you have an array of 1 million, you only need 20 comparison to know if the element is there or not, and if it's there at what position. But in linear search, you need 1 million comparison. The disadvantage that if you want to apply binary search, the array has to be sorted in advance. So now let's move to talk about sorting algorithm. Like the first problem was searching algorithm. We want to search element in an array. Now we want to sort the elements of the array. So sort is that we have elements, maybe that's words. We want to order them alphabetical order, or they are numbers. We want to order them from the smallest to the largest, and so on. We have two algorithms here. The first one is called bubble sort. Second one is called selection sort. So what's the bubble sort? In the bubble sort, you compare the first two elements. If they are in the correct order, we keep them. If not, we swap them. For example, let's take this array an example. We compare 17 and 23. Are they in the correct order? Yes, because 17 is less than 23, so they are in the correct order. Imagine we are ordering it from the smallest to the largest. And then we move to the second pair, 30, 23, and 5. Are they in the correct order? No, because 5 is less than 23. So in this case, we swap them. We make the 5 here and 23 here. So, and then you compare 5. So, and then you compare this. There is a small mistake in the slide. So here, normally you bring 5 here and 23 here. Okay. And then when you compare here 23 with 11, you bring 11 here and 23 here. So at the end, you have this. The array will be like this. So after the first pass, the array will not be sorted, but at least we sorted one element, which is 23 is the largest, will be in the last element. So we do another pass. So we compare 17 with 5. 5 is less, so we swap. So 5 has to be here and 17 here. And then we compare 17 with 11. It's not correct order, so 11 has to be here and 17 has to be here. So after the second part, so it will be like this, 5, 11, 17. Then we do another pass to make sure 5 and 11, they are in the correct position. So we continue, they are in the correct position. We continue, they are in the correct position. So there is no swap. If we make a pass with no swap, this means the array is already sorted. So this is the idea of the bubble sort, and this is the code. We will discuss it more in the class. So the benefit of the bubble sort, it's easy to understand and implement, but it's inefficient for large array. Because if you have 1 million, array of 1 million, you need 1,000 billion, like you need 1 million square comparisons, which is a lot of time. It's slow. We have another thing called selection sort. Selection sort, this means you go to the array, you look the smallest one, and then you swap it with the first element. And then for the rest of the array, you look for the smallest one, you swap it with the second element, and so on. So, for example, this array, you look the smallest, which is the smallest? 2. You swap it with 11. So you make 2 here and 11 here. And then, so 2 is sorted. And then for the rest, you look the smallest. Smallest is 3. You swap it with the second position. So 3 is here. And then for the rest, you look the smallest, which is 11. You swap it with the third element, and so on, until you are done with the array. So in this case, you sort the array. This is the code. The benefit, it's more efficient than bubble sort since we make small swapping, but the disadvantage, it may not be easy as bubble sort to understand. So this is about selection sort. So to summarize, in this chapter we learn searching algorithms, two searching algorithm and two sorting algorithm. We learn linear search and binary search, and we learn bubble sort and selection sort. Thank you, and see you in the next video.